Let us solve a question on how to apply the first and second order conditions for profit maximization. The question is, for a firm with the following total cost and demand function, we have the cost function as C is equal to 1 upon 3 Q cube minus 7 Q square plus 111 Q plus 50. This is the cost function of a firm. Q denotes the output, C is the total cost. Also, we are being given the demand function for the firm as Q is equal to 100 minus P. P denotes the price. We have to find out the profit maximizing level of output. Okay, so we know that profit is maximized. Okay, so profit, or let me write it here, there are two conditions. First order condition for profit maximization requires that we equate the marginal revenue of the firm with its marginal cost, and we have to apply the second order condition also here. I will explain them. Second order condition requires that at the intersection of marginal revenue and marginal cost, slope of, let me write it here, slope of MC should be greater than slope of the marginal revenue function. Okay, these are the two conditions. So let us go to the question. First, we need to find out the marginal revenue and marginal cost. So first we need to find out the total revenue. So given this demand function, first we write it in inverse demand function. That is, we solve this for P. That means price will be equal to 100 minus Q. Simple transposition I have done here. Then we need to find out the total revenue. Total revenue, as we know, is equal to price into output, which implies P is equal to 100 minus Q. To this we multiply by Q. So we will get the total revenue of the firm equal to 100 Q minus Q square. Then we can find the marginal revenue as simply the change in the total revenue due to the change in the output. That is the derivative of this function with respect to Q. Derivative of Q in the first term is 1. We are left with 100, and derivative of Q square is 2Q. This is our marginal revenue function. Similarly, we need to find out the marginal cost function. That will be the change in the total cost due to the change in the output. That is the derivative of the cost function with respect to Q. So derivative of Q cube is 3Q. So we will get, if I write it here, so we have 1 upon 3 derivative of Q cube is 3Q square by power function rule minus, we have 2 becomes coefficient, we get 2 sevens are 14, or let me write it here, 7 times 2 raised power Q, and exponent is subtracted by 1. Then we get derivative of Q in the third term is 1. We are left with 111, and derivative of a constant is 0. 3 and 3 gets cancelled, so we will be left with Q square minus 14Q plus 111. Okay, having said that, let us apply the first order condition. Requires we equate the marginal revenue with the marginal cost. So this is our marginal revenue function, this is our marginal cost. We equate them with each other. So we have 100 minus 2Q, which is our marginal revenue, and we equate it with the marginal cost function, which is Q square minus 14Q plus 111. Okay, now let us solve this for Q, transposing these terms here. So we will get Q square minus 14Q plus 111. So it becomes minus 100, then this becomes plus 2Q, and we set it equal to 0. So let us solve further. So we have Q square, let's write it here, we have Q square, then we have minus 14Q plus 2Q is minus 12Q, then we have 111 minus 100, it is equal to plus 11, and we set it equal to 0. This is our quadratic function. We can solve this splitting the middle term. That means we should get the sum of two numbers should be equal to the coefficient of the middle term, which is minus 12, and the product of the same two numbers should be equal to the constant term, which is equal to 11. Okay, you can use trial and error method. So let us see, doing the guess, can we write minus 11 plus minus 1? So minus 11 plus minus 1 is minus 12, and minus 11 into minus 1 is equal to minus into minus is plus, it becomes 11. So minus 11 and minus 1 will satisfy the given relationship. So we have q square minus, in place of minus 12q we write minus 11q and minus q. In place of plus 11, can I write it like this? Minus 11 times minus 1, and we set it equal to 0. Next we need to do another thing. Let us take q common in the first two terms. So q taking common, we are left with q minus 11. In the last two terms, let us take minus 1 common, we are left with q minus 11. You can see it by yourself, which implies, let's take q minus 11 common, then we will be left with q minus 1, and we set it equal to 0. It implies here either q minus 11 is equal to 0 or q minus 1 is equal to 0. So which implies q is equal to plus 11 and q is equal to 1. Since we got two values for q, that is why we are supposed to check the second order condition. Okay, so you can see when we equate the marginal revenue with the marginal cost, we got two. It looks like this if I can draw it roughly. So where is our marginal revenue function? This is downward sloping like this. This is our marginal revenue function. Then we have the marginal cost function. This is our marginal cost function. So it looks like this. Okay, this is our marginal cost function. Okay, we have output here and we have price or marginal revenue and marginal cost on the vertical axis. What happens here? First order condition is satisfied at 2 pointers when q is equal to 1 and q is equal to 11, because we got the two values for q. This is not sufficient condition. We need to check the second order condition, at which of these pointers is our profit is maximizer. For that, what we need to ensure, that means at the intersection of marginal revenue and marginal cost function, okay, the slope of the marginal cost function should be greater than that of the slope of the marginal revenue function. Okay, here you can see that at this point the slope of marginal revenue function is greater than that of the marginal cost function. Here you can see the slope at this point, the slope of the marginal cost is positive and the marginal revenue function is negative. That means at this point the slope of marginal cost function is, I'm just giving you a rough idea what we need to find out at the second order condition. So at this point the slope of MC is greater than the slope of marginal revenue, but at this point the slope of the MC is less than that of the slope of the marginal revenue function. And let's now try to explain the second order condition. So we are done with the first order condition. Now we need to check the second order condition. So what happens at second order condition? We should get, that is the slope. We need to compare the slope of marginal cost function and slope of marginal revenue function. Okay, what is the slope of marginal cost function? That is the derivative of the marginal cost function again. So let us write it. What is the slope of the marginal cost function? It is the derivative of the marginal cost function again, okay, or the second derivative of the total cost function. This marginal cost is the first derivative, and when we take the derivative of the first derivative, we get the second derivative. That gives us the slope of the marginal cost function. Now derivative of q square will be 2q. Derivative of q will be 1. We are left with 14. Okay, what about marginal revenue function? So the derivative of the marginal revenue function, so derivative of marginal revenue function gives us the slope of the marginal revenue function. So we need to differentiate marginal revenue function this time with respect to q. Derivative of q will be 1, constant, its derivative is 0, so we are left with minus 2. Okay, slope of marginal cost function came out to be, and if you are wondering. So we write it like this: slope of marginal cost function is simply the derivative of marginal cost function with respect to output. That means we need to differentiate marginal cost function with respect to q. Derivative of q square is 2q minus derivative of q is 1, so we are left with minus 14. This is the slope of the marginal cost function. Similarly, slope of marginal revenue function implies the derivative of marginal revenue function with respect to output. That means differentiating this marginal revenue function again. Derivative of a constant is 0, derivative of q will be 1, we are left with minus 2. Okay, I have explained it how to write it. Okay, so let me now rub this out. Now we need to check them at the two critical points. When q is equal to 1, when q is equal to 1, what happens? So when q is equal to 1, it implies we have 2 into 1 minus 14, and here since we don't have any q, so we have here minus 2. So this becomes 2 minus 14, which is equal to minus 12, and here we have minus 2. Here you can see minus 2 is greater than minus 12. That means slope of marginal revenue function is greater than that of the marginal cost function. That means when q is equal to 1, profit is not maximized. Okay, I will explain it graphically also. Now when q is equal to 11, when q is equal to 11, let us see what happens. So we need to evaluate the second derivative at the critical point q is equal to 11. Okay, now when q is equal to 11, what will be the slope of marginal cost function? Simply plug q is equal to 11 in this function, so we have 2 into 11 minus 14, and here we have minus 2, so it is 22 minus 14. Here we have minus 2. Here you can see we get here plus 8, so we get 8 minus 2. Here you can see the slope of the marginal cost function is greater than that of the slope of the marginal revenue. That means profit is maximized when q is equal to 11. And graphically, what exactly is meant by this, I have explained it earlier also. So if this is our marginal revenue function, and here we have the marginal cost function. So at this point q is equal to 1, and here q is equal to 11. Here the slope of the marginal revenue function is greater than that of the marginal cost function, but at this point the slope of the marginal cost function is greater than that of the marginal revenue function. That means when q is equal to 11, profit is maximized. I hope I make myself clear in this video and you find out this video helpful. Thank you. Jalla Shanu.